This episode is sponsored by Headspace. Welcome back. It is lovely to have you here for part 3 of making a steam power hammer. It just happens to be a little itty bitty one. We got this component made up in the last episode. It is called the mouthpiece, and right now we're going to get started on the component that fits inside it. That is component number 2, and it is the gland. What these two pieces do together is hold the ram from rotating, thanks to the capsule cutout both pieces share, and it also compresses the gland packing. See this part number 7. We've actually got it right here. It is a graphite-infused cord or yarn of some sort. It gets squished inside that little countersunk area once it's been wrapped around the piston, and it means that we have this semi-pliable seal to take up any imperfections on the piston rod and the holes that we made for it to pass through, hopefully stopping any compressed air or steam leaking. I believe this is the bit of metal that they have supplied for us to start from. It's probably cast iron. They really don't give you a lot of extra for work holding, let me tell you that. Oh my goodness. I only have 20 thousandths of an inch to spare lengthwise. Ah, you're kidding me. No! I already made that identical arbor. I wasted all that time making the exact same thing. Woo! Perfect! All right, so we are now out of the lathe. We are in the milling machine. And I really appreciate everybody's advice to go check out Joe Pye on YouTube. I also appreciate him reaching out directly to me to recommend that I look at his videos. In the past, I've looked at them, watched tons of his videos back in the day when I was learning machining. But of course, since then, I've forgotten a lot, and you're only as ripe for knowledge as you are in that moment. So what I'm doing here is I'm getting this thing indicated in. And when I was doing this the other week, I had this indicator in this really annoying orientation. Small little tips, like having the dial facing up, incredibly helpful. All right, we've got that thing dead nuts zeroed out. Something's not bloody right. Crap. That's not normal. We're not in the middle. How is this not in the middle? I indicated everything. Made it with a mandrel. We're not in the middle. What? How's it that far off center? How did we get so far off? I have no idea, but should be good now. Ah! Crap! We'll just push it right back in, and then we'll pretend that absolutely nothing happened. I'm really surprised with how well that little 4340 slotting tool has held up. I'm incredibly surprised at how well the Bridgeport milling machine works. Very unconventionally, mind you, for slotting. And the result of all that work is this one tiny, seemingly unimportant part that fits perfectly into the piece that I made last week, which makes me so happy. But you remember episode 1 where I was getting panicked about how long this was gonna take? Well, so far, I have not done a single thing to this thing that took less than a day. And as I said, the numbers go up to 47 on this thing. So if so far, every single tiny little thing is taking me a day, I'm gonna be here a bloody long while. Which doesn't actually upset me too much. Because right now, I am having just the best time in the workshop.
You kidding me? Why are you not swearing?
I'm so happy to be freshening up these machining skills.
I've been chasing square on this thing for an hour.
Because everything machining that I've done in a while has been quite clunky and kind of get it done type of stuff. But here I need actual precision, and I need to work to drawings for the first time ever. And all of this feels so far out of my comfort zone, and I feel like that is exactly what I needed. I just really hope that we can keep this entertaining and enjoyable for you through this series. I hope it doesn't become a bore, because at this moment right now, this is exactly what I want to be making videos about. What I've already learned from making this larger component down here is I need to pay attention to how deep I go with those drill and tapped holes, because I've actually poked through just a little bit on about all of them, and it's quite ugly. I need to do a neater job of cleaning up that stuff, because it just looks awful. So we'll probably need to do a touch of modifying on this at some point if we have time. But for now, we're gonna have to take these lessons on to the future pieces. It's time for some making. Making what, you say? A really fun, easy part. Let's make the part with the 90-degree holes, why don't we? Easy peasy. Called the cylinder. Number 11. So let's refresh our memory on the exploded view. We just made the gland. This is the mouthpiece. That is the cylinder. And this is what it needs to come from. Oh, have we had another delivery? Jamie, you know why I like this project so much? Because we keep getting more tools. Oh, what is this? Oh, that is a little baby tool maker's vise. I think to describe it simply, it's a vise that you put inside of another vise. All right. Cheapo, completely unbranded telescoping gauge set. I have a Michitoyo set. Hopefully this does the trick. You put this inside a bore, you tighten off the little screw, and then you can take a set of calipers or a micrometer to it before releasing it. Cutting oil. Aha! Yes, a little mirror for getting behind things. It's got a light. I've always wanted a set of these. A set of adjustable parallels. After having to make our little slotting tool from 4340, I figured I should have some more high-speed steel blanks on hand, as well as a little silver steel. It's just high carbon steel that's been precisely ground. Most importantly for this component we're working on, this big old 1-inch reamer. And with that, it's back to work. I lied! We've got another package! And it's a heavy one! It's a cheapo granite surface plate. We have needed one in here, and conveniently we can use it right now. I need to get some measurements and check how square we are. Okay, we're within 1/1000th of an inch.
You're all right.
This is just challenging. I'm trying to get this thing square and perfect, and every time I take it out and put it back in, I feel like it's not square and perfect. More stressful than I would like.
Why don't you use your ass?
Probably not a bad time for a little 60 seconds of breathing, eh? What do they have for me? 60 seconds of mindful breathing. That was Headspace, which is the sponsor of today's episode, and it's a mindfulness and meditation app. The inside of my brain usually feels like this. And so finding time to actually relax, decompress, and be present in the moment right here is something that I struggle with. And this especially impacts my sleep. I find it incredibly difficult to go to sleep, and I've found that Headspace's guided meditations and sleep casts, specifically for getting to sleep, have been incredibly useful. When during the day my brain is feeling a little bit too much like this, I really feel the benefits of meditation and focusing on my breath. But when I didn't have Headspace, it was harder to get in that zone, to properly relax, be present, and take those important moments for myself. Meditating isn't something that necessarily requires 30 minutes to dedicate to. In even a minute, you can get control over your breathing and feel calmer, and they have tons of guides to follow along to. So if you want to see if Headspace can be useful for you, please click my link in the description below or scan the QR code on screen to get a 60-day free trial instead of the usual week or 2 weeks. I'm feeling better. Let's get back to work. All right, so it's a new morning. The first thing that I did today is I actually retrammed the head of the mill just to make sure that it was dead nuts. What I mean by tramming a mill is these Bridgeports can rotate their head this way, that way, as well as nodding forwards and back. And it's incredibly important to ensure that the spindle is square to the surfaces that we're using as flat, because otherwise everything's gonna go all cattywampus. And when it is that we get to boring our cylinder bore, we need a mill that is just so square. It's just unbelievable. But I don't think I had unbelievable squareness on there, and when I put the dial test indicator on it, I actually found that I've been doing this much of the project with the mill about 1/1000th of an inch out of square. What you'll see right here is our part is now upside down with the back face facing upwards. We're going to ensure that it is sitting nice and square this way as well as that way. It should be. Those two faces are square. And we're going to take off some of this material. Now, on the drawings, we have a very important dimension, and that is this 7/8 gap between this back face and the center of our 1-inch bore. Our bore is currently a rough cast hole. It's nowhere near the 1-inch final size that it's going to be. But we don't want to just put the hole anywhere and be boring this off-center hole through the existing hole in the casting. And so I took a rough measurement from that hole. Not really rough, it was as accurate as I could. And in the previous setup, I milled this little ledge 1/1000th of an inch proud of where we need to bring this face down to in order for the rough cast hole bore to line up as close as possible to the final hole center of the final bore relative to that back face. Good Lord, this sounds really complicated. So now we're bringing that back face to size and then resetting it up in the mill to begin our boring operation. Change of plans. We're gonna put some holes in the back here while it's set up. All right, so we got all the holes done. And while doing it, the delivery driver's dropped off more stuff for us. What did we order this time? Ah, yes. Now, I actually already have one of these, sitting in a pallet.
Oh, can you knock it off?
This is an adapter so that we can fit our Morse taper reamer inside the Bridgeport mill. We're going to be needing that. That's for that big hole.
Is that bee's nest?
It's a bee's nest, yes.
Without the honey? Mm-hmm. It's just comb without the honey.
Oh, fabulous. More tools I don't need.
They look like little bits of cheese.
Yeah, they really do. Precision angle set. That's a 20-degree angle. In fact, I don't believe I have any use for that with this project, but one day, I've got it. So we've been chatting about that bore for a long time, and it seems like it's never time, but now it is the time. This is gonna go in the vise. We're gonna reference off of this back face and these two sides. That'll give us the middle, and then we're gonna move across 7/8 of an inch, where we're going to use a boring bar to begin opening this up. I think I've run into the old buy once, cry once problem with this boring bar. Now, as you know, a good craftsman blames his tools always. The way this boring bar works is our cutter is held in this light grey bit, which is dovetailed into this darker section, and then there is a screw with a micrometer dial. Whenever you want to change the settings, you get these a little bit looser, you turn the micrometer dial, you then tighten up those grub screws, and you should be good. Now, here's the thing. I took a record of every single move I made, and not a single one of them produced the same result. There was nothing consistent about it. And I think part of that is because there's a load of backlash in this thing. You can kind of spin it both ways, and I always make sure to snug it up to compensate for the backlash. But even then, there's funkiness that happens with that stupid boring head, and it's one of two things. One, it's a cheap piece of crap. And that's a possibility because it is the cheapest boring head I could buy. Option number two, I don't know how to use a boring head well enough. And I have experimented, and I've been making sure to kind of just gingerly snug and unsnug these things to make sure there's a little variation and room for things to go weird. But despite that, the very, very top of this hole is 1 inch and 2/1000ths of an inch, and the rest of it is 997/1000ths of an inch. So we've got this step, and we've got 3/1000ths of an inch to go to get this perfect elsewhere. So I think it might be time to say, enough with the boring bar. We don't trust you. You're unreliable. And maybe I just don't know how to use you. And now we switch to the old Mac Daddy. There we go, low range. All right, if this doesn't work, there's another option. I hope this works and makes a nice surface finish though. I've never reamed a hole this big.
I bet you haven't.
Oh, listen. It's cutting. Oh.
Why put maple syrup on it?
Oh, that's special machinist's maple syrup, Jamie. I really hope this gets it to the right size.
Doesn't really seem like it's doing anything.
It's gingerly cutting. Well, there's only 3/1000ths of an inch to cut, Jamie, provided this reamer is quite accurate. Oh, look at it. It's dripping out the bottom. It's like a regular Tuesday night. Oh, look at it go. Now we find out, is the surface finish any good? Oh, I quite like it. Moment of truth, we measure it. I want 1, 1, and a crap load of zeros. Oh, bugger! We're 1.5 thousandths proud. I guess I just learnt a lesson. Apparently my reamer will make my hole 1.5 thousandths proud. All right, holes drilled and tapped. And next up, we've got an interesting feature to put in. It's this little thing right here, and that is the port that lets air into the cylinder. Looking at the side view, you'll see there's this little recess. Well, that's this little semicircular feature that's cut down, and look back to find our 90-degree 1/8 hole opens up into that little semicircular feature. So it's quite an important part because this really affects the function of the machine. It's the port that's letting air into it. Now what's extra cool is I think we have seen on this channel a port in real size just like this. If you remember, we were taking apart the Chambersburg power hammer to get that running smoothly. When we took the head off the machine, there was that same port, just a lot bigger than the one that we have to make here today. Unfortunately, these drawings are not super clear. All I know is that it cuts in 7/32 of an inch. And we'll probably have to pull the other measurements off the drawing with a set of calipers. All right, so there it is. There's our port. Now remember that 1/8 inch hole goes all the way down, and I was meant to meet up just at this hole that we put in on the other setup. And have a look, you can see chippings in it. And I blow it with air. Woo-hoo! We've done it, the holes line up. I love it. Oh, look, you can see daylight. That is a long hole to make line up. I'm very happy. It means our setup can't have been too bad. We're learning stuff. Now we do the same on this side. It's identical. Well, would you look at that? That is our cylinder. Done. I really hope you guys are enjoying these videos. Please, I ask now very sincerely, please watch the next one. Maybe even like it. I never ask for that. And if you don't want to watch the series, can you just open a tab and just let it watch in the background or something like that? Just in case this project kills our YouTube channel and Jamie becomes hungry. Think of Jamie. Don't forget that massively extended free trial from today's sponsor, Headspace. Click the link down below. Oh no, Jamie. You know what's next? It can't be. Find out next time. Do you have any ways that we could make this a really exciting outro where
That
people...
was really cringe, and I'm going to leave that in. There you go. Done.